This problem is looking at solving a rational equation. We know this is a rational equation because each of the terms are written as fractions, and a rational can be written as a fraction. The first step in this is going to be determining what is our least common denominator. So we really want to look at all of our denominators. We have x minus 1, we have x plus 3, and we have x squared plus 2x minus 3. Now we want to look at the denominators and make sure they're completely factored. So this one's completely factored, this one is also, this one is not. So how could we write this in factored form? So this one could be written as x is in the front, and then what are the factors of -3 that give us 2? And that's going to be 3 and 1, and the signs will be different because this is negative. And the bigger number, the bigger factor here is going to be whatever this sign is. So if this is a positive, the 3 will be positive, and the other sign will be different, which will be negative. So I'm going to mark through this, and I just want to look at each of these things. So we do want to look at the factored form. Now, if we're looking to find the LCD, what we're going to do is just kind of take the first one. So we have x minus 1. And if we've used that x minus 1, that's going to really take the place of using it here and here. So anytime that you're using something in your LCD, you don't have to write it again if it shows up later. All right? All right, now we need an x plus 3, and that's going to take care of that one and that one. So notice, again, even though it was here and here, I only wrote it one time, and I don't have to write it twice, even if it shows up later. Now, the only time I would write it twice is if it ended up in the same denominator. So, for example, if this was x plus 3 and x plus 3, I would have to have both of those in this LCD. But in this problem, it's not like that. So our LCD is x minus 1 times x plus 3. This method of solving a rational equation is multiplying that LCD by each of the terms and then seeing what cancels. So this is going to be kind of long for this first step, but hopefully things will cancel and we'll be left with something that's a little easier to solve. So our first step is to write our LCD, and that's x minus 1 times x plus 3. And just as a note, it doesn't matter what order you put those in. And then we're going to bring down this first term, which is x plus 1 over x minus 1. Bring down your equal sign. And we're writing the LCD again. So we're multiplying by the next term. So x minus 1 times x plus 3. And our next term is -6 over x plus 3. And then we're going to bring down this plus sign, and we're going to write our LCD again. And we're going to bring down this last term, and we want to write that denominator in the factored form. So the factored form was this x plus 3, x minus 1. Our next step is to cancel. So let's see what can cancel. Hopefully, if we've done this right, all the fractions will go away. They will cancel. So right here we have x minus 1. You can consider these terms on the outside in the numerator, and these are in the denominator. But because this is all together, this is kind of all one big term right now, one big expression, then we can actually cancel across the parentheses. So if this is in the numerator and this is in the denominator and those are the same, those will cancel out. So what do I have left here? I have x plus 3 and x plus 1, excuse me. Let's look at the next set. So if I'm looking at this set, I have an x plus 3 in the denominator. That will cancel with this x plus 3 in the numerator. Now we want to write this -6 first and then bring down the x minus 1 just to make it look better. And our last set, is going to be great because we have x plus 3 that can cancel, and we have x minus 1 that can cancel. So in this last term, I'm just going to have 8. All right, we have some simplification to do here. So when we see this set two binomials multiplied together, remember that is FOIL method. So first outer, inner, last, or first outside, inside, last. So we're going to have to do some work here. So let's multiply. We have x squared plus x. So 1x is just x. And then 3 times x is 3x. And 3 times 1 is 3. All right, let's keep going. This is going to be distributive property. So we get negative 6x. 2 negatives make a positive 6. And then bring down the 8. Next step, we're going to add like terms before we do anything else. So this is going to be x squared. And when we combine those like terms, we get 4x plus 3 equals negative 6x plus 14. At this point, we notice that this is a quadratic equation. It's quadratic because we have an x squared as our highest exponent on the variable. So we have a square there with our variable. Our process for solving quadratic equations is to set it equal to 0 and then factor. So let's set this equal to 0, and we're going to do that by moving the 6 over. Remember, you change the sign when you move it across the equal sign. I'll do this in parts. So we've got x squared plus 10x plus 3 equals 14. Then let's move the 14 over. We get x squared plus 10x minus 11 equals 0. Now that we have this equal to 0, we want to factor the left side. Now we can use a little easier method of factoring, kind of like we did in our LCD, and mainly because that a is equal to 1. So we can just do a simpler version of factoring here, no need to do grouping or any other method. And we're thinking, what are the factors of negative 11 that multiply to give you 10? So 11 is just 1 times 11, so that's the only two choices. Because this is negative, our factor signs will be different. Because this is positive, our bigger factor is also positive. So if this is positive and we know they're different, this is negative. Now that we have this factored, we want to set each factor equal to 0. And x minus 1 equals 0. And now we're going to solve. So minus 11 on both sides, x equals negative 11, and then plus 1 on both sides, and x equals 1. So we get the answers negative 11 and 1. This is really important. We have to check to see if these answers are valid. So these are just the potential answers. We're not quite sure if these will actually work out. And here's why. Our original problem was a rational equation. It had fractions in it. And if you think about all the things you've learned in mathematics, you've probably heard before that fractions cannot have 0 in the denominator. And anything that we get as a solution that makes any of these denominators 0 would not be a valid solution. So we cannot consider that as part of our solution. So what I want to do is, we know that we took all of these denominators and we found our LCD of x minus 1 and x plus 3. I'm going to write our LCD down here so we can see it. And we know that if we plug in any of these numbers into this LCD, those are coming from our denominators. So if we plug in our solutions, negative 11 and 1, and this gives us over here 0 in any way, shape, or form, then that means that one of the denominators is going to be 0, and that means that that solution is not a valid solution. That potential solution is not a valid solution. So this is how you're going to check it. You're going to take the first one, negative 11, and just plug it into both of these factors, these denominators. So I've got negative 11 minus 1 and negative 11 plus 3. The big question is, does this equal 0? So does this equal 0? This is going to be negative 12 and what? Negative 8. And I multiply those. That's not going to give me 0. So if the answer is no, then we know that negative 11 is one of the answers. Let's look at 1. So I'm going to do the same thing, plugging in 1 for both of these. 1 minus 1 and 1 plus 3. Does this equal 0? Well, 1 minus 1 is 0, and 0 times anything is 0. So we do have something that equals 0, and that means that this 1 right here is not going to be a valid answer. So even if you get everything and it works out perfectly and you have these nice little whole number answers, they may not all work in this rational equation. They may not all be valid answers. So the only answer we have on this one is negative 11. You cannot use the 1 as a solution. So that's one way to solve a rational equation.